So we've got the sum from 1 to 16 of 3r plus 2 to the power r plus k is equal to 131,550, and we need to find k. So I can see that this part here of this rule would give me an arithmetic sequence, because when r equals 1, I would get 3. When r equals 2, I would get 6. When r equals 3, I would get 9, and so on. So I have an arithmetic sequence where the first term is 3, the common difference is 3, and there are 16 terms in that sequence. So that would allow me to work out the sum for that. The sum is n over 2a plus n minus 1 times d. So substituting the numbers in here, I get 8 times 6 plus 45, so 8 times 51, which is 408. So that's the sum of the first 16 numbers just for the 3r part. Now let's do the 2 to the power r. When r equals 1, I would get 2. 2 to the power 1 is 2. When r is 2, I'd get 4 because 2 to the power 2. When r is 3, I would get 8. 2 to the power 3. 2 to the power 4 is 16, and so on. So I've got a geometric sequence where the first term is 2, the common ratio is 2, and again there are 16 numbers. The sum for this geometric sequence is going to be a times 1 minus r to the power n over 1 minus r. So that's 2 times 1 minus 2 to the power 16 over 1 minus 2. And I've not got a calculator to hand, but we can put that into a calculator and work out what that would be. Finally, we've got the sum of k on the end here. Now, k is just a constant, so it doesn't matter what r is here. So when r is 1, I would just have k. When r is 2, I would just have k. When r is 3, I would just have k, and so on and so on. So basically, I'm adding k 16 times, which would just be 16k. If I'm just adding k, a constant number, 16 times, that would just be 16k. So, what I can do now, I've worked out each of these terms separately. I can then add up the sums of those. So I've got 408 plus whatever my answer from the calculator was here, plus 16k is equal to 131,550. I can now take all of this away from both sides and then divide by 16 to work out what k is.